Good afternoon. I am here in order to show you what a trigonometric substitution by integral is. Integral by trigonometric substitution. Now, first of all, when do we use it? Basically, you use it when you see any trigonometric opportunities, such as if we have an integral of 1 over square root of 9 plus x squared, we can easily see here that square root of 9 plus x squared is equal to square root of 3 squared plus x squared. And we know that the square root of a square of another square is going to give you c, which is hypotenuse. So we can easily draw that as a triangle. That is when we can actually apply this triangle in order to find a trigonometric substitution. This is when you use it. When you see any type of opportunity to use any trigonometric identity or a substitution inside an integral like this. Now, the second question we must ask is, what's the idea behind it? Now, the example I will teach you right now, or explain to you right now, bases itself on the drawing of a triangle. A triangle explains to us how the relationship between this angle and the values we have in between each other work. And basing on these values, we're going to be able to simplify the integral in order for us to have a different or a simplified version of this integral, whatever it is. Now, the final question that we must answer right now is how many types of substitution exist? Now, we know substitution by variables. We learned this. We did integration by parts. But here, in this example, in this video, what I'm going to focus on are three different cases. And these three different cases are case 1. Case 1 is when we actually take into account the value a squared minus x squared. Case number 2 is when we evaluate square root of a squared plus x squared, okay? And the last case number 3, is when we evaluate square root of x squared minus a squared, okay? So here we have three different examples where it's the same thing. It's basically different parts of the Pythagorean theorem, which is a squared plus b squared is equal to c squared. Now, if we try to find c, we're going to have c is equal to the square root of a squared plus b squared. And this is where it all comes from. If we can see any of this three, or see applications of it inside an integral like we said above, then we can apply the substitution of trigonometric substitution inside an integral to simplify it and to solve it with ease, okay?